Hello, good morning. I'm Sonali here. We are in Education on Cloud. For class 10 science, we have a chapter named electricity. So let us do quick revision for this chapter. There are two kinds of electric charges. One is called positive charge and one is called negative charge. Let us see first. Okay, so one is called positive and one is called negative. The opposite charges attracts each other and similar charges repel each other. Okay, so coulomb is the standard unit of charge. So we can say here 1 Faraday is equal to 96,500 coulombs. This will be the relationship. Okay, conductors, the substances which can conduct electricity, the substance through which electricity can flow are called conductors. So like silver, copper, gold, aluminium are examples of conductors. So these are all metals are very good conductors. So silver, copper, gold and aluminium are the examples of conductors. Okay, why? Apart from this, there are, like we can say, strong acids, strong bases, salt, they are also very good conductor in the aqueous form or the molten form. Okay, so like they ionize into their particular ions and electricity is passed through ions, and here they are electronic conductors. So passage for electric current is via electrons. Okay, so here they are called electronic conductors. Okay, so passage for electric current via electrons. Okay, what are insulators? Insulators means the substances through which electricity cannot flow. They are called insulators. So like glass, wood, porcelain, rubber, these are all example of insulators. So insulators cannot provide passage for electric current, and there is a, if we talk about the energy gap or energy gaps valency gap theory, so in that we will see there is a large gap from the valence orbital to the excited orbital, and because of that jumping of electron to that level, electron requires lot of energy, and because of that insulators cannot, and they lose the energy when they jump it. Okay, so in that process, so the gap is very big, and because of that what happens, the conduction is not happening. 1 coulomb, a body is said to be have 1 coulomb charge if it has 6.25 into 10 power 18 electrons on it, or it is deficient as compared to the normal number of electrons. Okay, electric current, what do you understand by electric current term? Okay, so the rate of flow of charge from a body of a higher potential to body of a lower potential, from a body of higher potential to body of lower potential, rate of flow of charge is only called electric current, and the SI unit, standard unit of current, SI unit for electric current is ampere. Okay, electrode potential or electric potential, we will see amount of work done in moving a unit positive charge from infinity to a given point in an electric field is called electric potential. So the electric potential is a condition which determines the direction of flow of charge. So the unit of electric potential will be volts. Okay, so now what is potential difference? Potential difference is the amount of work done in moving unit positive charge from one point to another in an electric field, that is only called potential difference. Okay, so potential difference means like when two electrodes will be there, one is positive, one is negative electrode, and one electrode undergoes there is oxidation at one electrode, in a redox reaction we can talk, and the reduction on another electrode. So in that case what will happen, the electrical double layer will form, and that will only be the cause of generation of potential, and that is only called the potential difference will be present, and that potential is called electrode potential, and the potential difference is amount of work done in moving a unit positive charge from one point to another point in an electric field. Okay, now closed electric circuit. What do you mean by closed electric circuit? An electric circuit which is all the components are joined to one another such that continuous current will flow through them. They are only called closed electric circuit. Like we can say here, if we have two half cells, okay, and there are electrodes, and externally they are connected with a copper wire, and internally their liquid is connected with the salt bridge. Okay, so this is called salt bridge. Here there will be electrolyte, and here there will be electrode, and here there will be copper wire. So this will be having a positive end, this will be having a negative end. One is anode, one is cathode. Then open electric circuit means what? Open circuit means which electric contact is broken at some point, say by switch, such that no current flows through the components of the circuit. That is only called open electric circuit. Okay. Electric resistance. What do you mean by resistance? The opposition of obstruction offered. So which is hindrance in the flow of current or conductors. That is only called resistance. So offered by a conductor to flow of electrons, electrical resistance. So SI unit will be ohm, or it is also called mho. Okay. Resistivity means it is the amount of resistance offered by the conductors of unit length and unit area of cross section such that current enters and leaves from its opposite phase. That is only called as resistivity or specific resistance. Okay. Now series circuit of resistors, when a number of resistors are connected end to end such that tail end of one resistor is connected to initial end of other resistors so that it is form a closed circuit, then such circuit is called series circuit of the resistors. Okay, and the parallel circuit will be here. The series circuit we have seen when a number of resistors are connected in such a way that they have common positive terminal and a common negative terminal, that the resistors are said to be connected in parallel circuit. Okay, so parallel and series type of connections are there. Then Ohm's law. What do you mean by Ohm's law? Ohm's law is all physical condition of a conductor remaining same. The current flowing through is directly proportional to potential difference. Okay, so current flowing directly proportional to potential difference at its end. If I is the current such that V is the potential difference, so V is directly proportional to I. That is only Ohm's law, and the proportionality sign can be taken by a constant. V is equal to I into R. So R will be the constant for proportionality and commonly called as resistance of conductors. Okay, now electric work is done. Now electric work is said to be done when a charge flows through a conductor and some potential difference. If W is the amount of work done in carrying Q charge from one point to another in an electric field, so V is the potential difference. So what will be the formula? V is equal to W by Q, or we can say W is equal to V into Q. Okay, now what is electric power? Electric power is the rate of doing electric work, is only called electric power. The SI unit will be watt. Okay, so if the watt W is the amount of electric work done in T, then such that P is the power. So P will be equals to W by T, but W is equal to I square R into T. So P is equal to I square into R. Okay, so what do you understand by overloading? Overloading of circuit means passing more current through the circuit than it can tolerate without the damage. That is only called overloading. Okay, now short circuit. When short circuit happens? When it means that live and neutral wire come in a contact with each other, thereby passing the electric device. It is caused due to melting of insulation of connecting wires or the live wire getting connected to earth. Okay, so when it happens, so extra current is passed through it, and because of that what happens, it it can be short circuit, like live and neutral wires comes in a contact with each other. Okay. Now what do you mean by fuse? Fuse is a safety device, and it is used here in an electric circuit. It is the weakest point of an electric circuit which melts and breaks the electric circuit. They use such kind of metals inside it, elements inside it, which has a lowest melting point. So what happens whenever overpassing of a current happens, more extra current happens, so electrical appliances should not get damaged, so they should pass through fuse. So fuse wire will melt and fuse will go and the current will tripped off, and like that you can save the expensive electrical appliances from just sudden passing of lot of current in that. Otherwise short circuit can happen like that. So when the circuit gets overloaded, that time the inside the element melts, the wire melts, and the fuse gets the electric supply gets tripped off. Okay. What do you mean by charge? Charge is electrons have negative charge of 1.6 into 10 power minus 19 coulombs. Okay. And while protons have equal positive charge, that is 1.6 into 10 power minus 19 coulombs. Electric current is the quantity of electric charge flowing through a conductor in 1 second is called electric current. Current is I is equal to Q by T, that is current is equal to charge by time. Okay. Now SI unit of current, how we can divide? Like 1 coulomb by 1 second, so it gives 1 ampere. So small units of current here, 1 milliampere is equal to 10 power minus 3 ampere here, and 1 microampere is equal to 10 power minus 6 ampere. This will be the smaller units of current. Now current may be direct by saying varying or alternating current. Direct current, we can say, we can plot a graph T versus I, so we get a line, horizontal line parallel to the x-axis. Okay. And alternating current will be like this. You are seeing the wavering line, which is here there is a straight line parallel to x-axis, here there is a zigzag line, wavering of the line, that is called alternating current when we plot a graph T versus I. Now electric potential, if we discuss, the electric potential is work done in bringing a unit positive charge from a reference point to a point against any electric field. So V is work done by charge present. Okay. Now SI unit of electric potential is 1 joule by 1 coulomb is equal to 1 volt. Okay. Now electric potential difference, if we talk about electric potential difference, then the amount of work done in bringing unit positive charge from one point to another point in an electric circuit carrying current, that is VAB, is equal to VB minus VA, or we can say WB by Q and WA by Q. It has the same SI unit as electric potentials. Okay. Now electric potential energy, what do you mean by this? It means the work required to be done to bring the charges of their respective location against the electric field. Okay. So with the help of source of energy, this work done gets stored in the form of potential energy of the charge. So symbols of electric components will be, these are the different symbols. When you draw electric circuit, these symbols should be kept in the mind while drawing. Like electric cell will be drawn like this. Okay. Battery will be drawn like this. Lamp will be drawn like this. Electric bulb will be shown like this. Key will be, this is the open key and this is the closed key. Like that the symbols will be used when we draw the diagram. Now wire crossing, if two wires are crossing, we can show that resistors are shown with this kind of line. Rheostat can be shown like this. Okay. Or ammeter can be shown like this. Voltmeter with A here, with V here, galvanometer, G here, and AC source can be indicated like this. Okay. So these are the all indicators. Now Ohm's law. Ohm's law is, under physical conditions the current flowing through a conductor is directly proportional to difference in potential applied across its end. So I is proportional to V, so V is equal to I into R, so where R is the resistance offered. Okay. Now graphically, if we represent I versus V graph, if we take, so you are getting a straight line starting from the origin, so slope V by I is the measure of resistance offered, and the opposition caused to flow of current is called resistance. Okay. So the SI unit for resistance will be ohm, and the R will be equals to 1 1 volt by 1 ampere, that is 1 ohm. Now what are the factors which will affect the resistance here? Okay, so the first factor is length of the conductor. Now resistance of a conductor is directly proportional to length, so R is directly proportional to length L. So that is why here resistance will get affected if length of the conductor is changing, because R is directly proportional to L. Now area of cross section. Resistance is inversely proportional to area of cross section, so that is why we can say here R is inversely proportional to area of cross section, or R is proportional to 1 by A. Okay, so it will affect inversely. More the area of cross section, less will be the resistance, like that. Material of the conductor. If we talk about the material, now two resistors made up of same length and same area of different material have different resistance, like R is proportional to L by A, length by here area of cross section, R is resistance. So we can have proportionality sign by a constant called rho. So R is equal to rho L by A, or rho is equal to RA by L. Okay, now resistivity, rho can be taken as here ohm meter square by meter, so we can say ohm meter. Now temperature, with rise in temperature what will happen? Resistance of metal increases and decreases with decrease in temperature. Certainly alloy like nichrome, manganine, whose resistance vary negligibly with the temperature. So what will happen? Resistance change, rise in temperature, resistance of metal also increases. Because of that only conductance will decrease. Why? Because conductance is inversely proportional to resistance. Resistance is which is a hindrance in flow of current, correct? So if resistance, as we increase the temperature, resistance will start increasing, and because of that conductance will decrease. Now effect of temperature on resistivity. If we say there is a graph of T versus rho, so we can see here resistivity of a conductor increases linearly with increasing temperature. Okay, increases linearly with increase in temperature. Now resistivity of a semiconductor decreases with increase in temperature. Why increases with decrease in temperature? Okay, because we can say here resistivity of a semiconductor decreases with increase in temperature. We can see here resistivity of a semiconductor decreases with increase in temperature, because in semiconductors by increase in temperature conductance increases, that is why resistance decreases. Now resistivity increases with rise in temperature in insulator. So in insulator what happens? Increases resistivity with rise in temperature, that is why they cannot act as a good conductor. Now combination of resistance. Now we will see resistors in series. Okay, so in series, when resistors are placed in series, we can see here R1, R2, R3, and they had kept it in a series. This is the complete circuit. We can say here there is ammeter, there is a battery, there is a key here. Okay, and the flow of current direction is this to this. Okay, so we can see here this is called resistance in series. Now the current through them will be current through which will flow will be the same, and the sum of the potential difference or voltage across them is total potential difference. So V will be equals to V1 plus V2 plus V3, or I is equal to R1 plus R2 plus R3. So equivalent resistance will be given RS is equal to R1 plus R2 plus R3. So resistance in parallel, if we have to see, we can see here when resistance are parallel, R1, R2 or 3, it's connected like this. This is called resistance. They are parallel to each other. Okay, and here voltmeter, here ammeter, here battery, and there is a key here. Okay, so here the potential difference across the ends is the same, and the sum of the current through them drawn from the source of energy will be I is equal to I1 plus I2 plus I3, or V by Rp is equal to V by R1, V by R2 and plus V by R3. So equivalent resistance can be given by 1, that will be inversely proportional. So 1 by Rp is equal to 1 by R1 plus 1 by R2 plus 1 by R3. 3 will be. Okay. Now heating effect of electric current. We will see that how the heating effect of electric current is there. Like when electric current flows through the resistive element, the flowing charges suffer resistance and work has to be done to overcome this resistance, which is converted to heat energy. So the complete sequence, electrical energy does not does work which converts into heat energy here. And Joule's law of heating, Joule's law of heating is when a current I flows through a resistor, heat is produced. The heat produced depends directly on the square of the current, resistance and the time t for which current is allowed to pass through. So the formula is H is equal to I square R into T. Okay, this is only called Joule's law of heating. And electric power, if we are talking, electric power is the rate at which electrical energy is consumed or dissipated, is called electric power. Power is equal to work done by time, W by T. So P is equal to VI is equal to I square R. We can say V square by R is equal to QV by T. Okay. Now power is expressed in joule per second or watt. Practical units of electrical power will be horsepower. So 1 horsepower is equals to 746 watt. Now electrical energy. Electrical energy is equals to electrical power into time. Commercial unit of energy will be kilowatt hour. So kilowatt hour is 3.6 into 10 power 6 joules. Okay. Now electrical fuse, it is a safety device which is connected to a series with the electric circuit. It is a wire made up of material whose melting point is very low. Fuse wires are made up of copper or tin lead alloy. Now when large current flows through the circuit, hence through what will happen, fuse wire, large amount of heat is produced. Due to this, the fuse wire and the circuit is broken, and that is why current stops flowing. Okay, so through the circuit, this saves the electric circuit from burning and electrical appliances from getting damaged.